Remember geometry class? All those squares, triangles, and circles? We learned about angles, lengths, and areas. It all seemed pretty straightforward, right? Well, hold on to your protractors, folks, because the world of geometry just got a whole lot more interesting. There's a revolution happening in the world of shapes and spaces, and it's all thanks to a groundbreaking discovery that's turning our understanding of geometry on its head. You see, for decades, mathematicians have been grappling with a particular problem, a conjecture that seemed as solid as Pythagoras' theorem. But as it turns out, even the most fundamental assumptions in mathematics can be challenged. This isn't just some esoteric mathematical puzzle. It has implications for how we understand the very fabric of the universe, from the curvature of space-time to the behavior of subatomic particles. So buckle up, because we're about to embark on a journey into the fascinating world of topology and the mind-bending discovery that's changing everything we thought we knew about shapes and spaces. It's time to rethink those squares and circles, my friends. The universe of geometry is far more complex and intriguing than we ever imagined. Now, before we dive into the nitty-gritty of this groundbreaking discovery, we need to take a quick detour into the wonderful world of topology. Topology, you see, is like geometry's more flexible and adventurous cousin. It's not so concerned with precise measurements like lengths and angles. Instead, it's all about the fundamental properties of shapes and spaces, properties that remain unchanged even when you stretch, twist, or bend them. Imagine a donut. Now imagine stretching that donut into a coffee cup. To a topologist, those two shapes are essentially the same. They both have one hole, and that's what matters. Topology is all about those kinds of fundamental similarities, the underlying structure of shapes and spaces. So why is topology so important? Well, for one thing, it helps us understand the very fabric of the universe. Einstein's theory of general relativity, for example, describes gravity as a curvature of spacetime. And guess what? That curvature is a topological property. Topology is also crucial for understanding things like the behavior of fluids, the folding of proteins, and even the structure of our DNA. It's a pretty amazing field, wouldn't you say? And it's at the heart of this groundbreaking discovery that's shaking up the world of geometry. For over 50 years, mathematicians have been wrestling with a particular conjecture in the realm of topology and curvature. Now, I know what you're thinking. Conjecture? Curvature? This sounds complicated, but bear with me because it's actually quite simple, and rather elegant, if I may say so myself. This conjecture, which had a rather technical name that we won't bother with here, basically stated that if you take a shape with a certain kind of curvature, you can always find a particular kind of point on that shape. Think of it like this. You have a curved surface, like a saddle, and the conjecture said that there's always a special point on that saddle where the curvature behaves in a specific way. This conjecture had been tested and prodded for decades, and it seemed to hold true. Mathematicians had built up a whole body of work based on this assumption. It was like a cornerstone of the field, a fundamental truth that everyone just accepted. But as we all know, the universe loves to surprise us. Enter a team of brilliant mathematicians armed with their wits, their whiteboards, and perhaps a few too many cups of coffee. They set out to explore this 50-year-old conjecture, not to necessarily disprove it, but to understand it on a deeper level. They poked and prodded, twisted and turned, and explored the conjecture from every angle. And then, something amazing happened. They stumbled upon a counterexample. A what, you ask? A counterexample is like a wrench in the gears, a fly in the ointment, well, you get the picture. It's an example that proves a conjecture wrong. And this team of mathematicians had found one. They constructed a shape, a mind-bendingly complex shape, mind you, that satisfied all the conditions of the conjecture, but didn't have that special point that the conjecture said it should have. It was a mathematical mic drop, a moment that sent shockwaves through the world of topology and geometry. So, what happens when a 50-year-old mathematical conjecture gets blown out of the water? Well, for one thing, a lot of mathematicians start scratching their heads. You see, this conjecture wasn't just some isolated idea. It was a fundamental assumption that underpinned a whole body of work. The discovery of this counterexample sent mathematicians back to the drawing board, re-examining their assumptions and rethinking their approaches. It's a bit like discovering that the Earth is actually flat after all. It throws everything into question. But here's the thing about science and mathematics. These fields thrive on being challenged. Every discovery, even one that upends our understanding, opens up new avenues of exploration, new questions to ask, and new mysteries to unravel. The disproving of this 50-year-old conjecture is a testament to the power of human curiosity and the ever-evolving nature of our understanding of the universe. It reminds us that even in the seemingly rigid world of mathematics, there's always room for surprise, for innovation, and for a healthy dose of intellectual upheaval. This discovery isn't just about shapes and spaces. It's about the very nature of knowledge itself, about our constant quest to push the boundaries of what we know and to challenge the assumptions that underpin our understanding of the world. So, the next time you look at a donut, remember that it's not just a tasty treat. It's a symbol of the interconnectedness of shapes and spaces, a reminder that even the most fundamental truths can be challenged, and that the universe is full of surprises just waiting to be discovered. And who knows, maybe you'll be the one to make the next groundbreaking discovery, the one that turns our understanding of the universe on its head once again. Keep exploring, keep questioning, and never stop being curious. The universe is vast and full of wonders, and it's up to us to unravel its mysteries.